everyone, in this video we are going to determine if the two given equations of a line are parallel, perpendicular, or neither. In order that we can do that, the only part of the equation that we need to look at is their slope. So if two lines have the same slope, so that means if their slopes are the same, then they are parallel. If two lines have slopes that are opposite reciprocal, the word opposite reciprocal means that their signs switch, so it's either the other one is positive and the other one is negative, or the other one is negative, the other one is positive. It doesn't matter as long as their signs are being switched. Then the fractions, at the same time, if their fractions are flipped, that means the other fraction is the opposite of the other, then they are perpendicular. And if these two conditions that we have here, so these two conditions that we got here for parallel or perpendicular are not met, then we go ahead and say that the two lines are neither parallel or perpendicular. Neither or neither are both acceptable. Okay, so let's take this first example here. Are the two lines below parallel, perpendicular, or neither? So again, we can take neither for that. So in the first example, we have here the slope, which is represented as letter M. So the slope for this is 3/2. So that's 3 over 2. And then the slope for the other one is negative 2/3. So looking at their slopes here, we are going to take the first rule here in order that we can figure out if it's parallel. Are these two, the questions that we have to ask would be, are these two slopes the same or equal to each other? They are not, because that's 2/3, that's negative 2 over 3. Now the second test would be to determine if they're perpendicular. So first, are their signs opposite? Yes, that's the first. We have met the first condition for perpendicularity. So their signs are opposite. That means the other one is positive, the other one is negative. Now the other condition for line to be perpendicular is that their fraction is flipped. So let's see if the fraction have flipped, 3 over 2, 2 over 3. So that means that they are opposite reciprocal. So then we can go ahead and say that these two lines are perpendicular to each other. So that's perpendicular. Now let's take the second one right here. So again, we look at the M. So our M for this is 5/4. And then the M for the other one is 5/4. So again, the first test is to determine if they're parallel. Let's look at their slope. Are the two slopes the same or equal? Yes, they are, 5/4 and 5/4. So that means these two lines are parallel. Okay, now let's have the next example right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the first example here. So the slope of the first line here is 1/4. And then the slope for the other one is -4. Okay, so the first test is to determine if they are parallel. So the question that we're going to ask for parallel is that, are these two slopes the same or equal? They are not. So that means they are not parallel to each other. Now the second test is to determine if they are perpendicular. So there are two questions that we need to ask for perpendicular. Are their signs switched? Yes, positive and negative. So their signs are switched. The second condition for perpendicular is that, is the fraction switched or flipped? So this is 1 over 4, but then this is a -4. So others are going to think like, oh, but that is not a fraction. How can we determine if their fractions they're like opposite or reciprocal? Please remember that if it's a whole number, it has an invisible denominator of 1. So I'm gonna put this in broken line just to tell us that it's invisible. We may not be able to see it, but it's there, so it's invisible. So their signs have been switched, positive and negative. Now let's see the fraction. 1 over 4, 4 over 1. And the fraction is switched. So they were flipped. So that means this line that we have here is perpendicular since the two conditions are met. So we go ahead and write perpendicular. Now let's take the second example here. So we have 3x plus 5 and y equals 1/3 x minus 12. So let's find the slope for the first one. So our m here is 3. And then the slope for the second one here is 1/3. So this is, by the way, all of these lines are in slope-intercept form. That means it has the slope and the intercept at the same time. So that is pretty much like y equals mx plus b form. Okay, so we have here the second problem here. We're gonna look for their m value. Are these two m equal? They're not, so we can go ahead and say that they are not parallel. Now the second question is to test it if they are perpendicular. There are two questions that we need to ask for perpendicular. First, are the signs switched? So that is a positive and that's positive, so their sign is not switched. So that means pretty much this is not perpendicular. So then we can go ahead and say this is neither. So again, you can use the word neither or neither. They're just the same. Now others are gonna think like, oh, but you did not ask the second question on perpendicular, which is the fraction flipped. So we can go ahead and test that, but then it doesn't really matter because those two conditions for perpendicular should be met in order that we can tell that the two lines are perpendicular. Again, the first question is, are their signs switched? So their signs are not switched, so we don't have to go through the second question. You can do that, but then it doesn't really matter because it has to be those two conditions. So that's neither. Now let's take the, did you get the same answers for both of these? Good. Perfect. Now let's move on to the second problem that we have here on this slide. Now in this problem, we are given an equation of a line in general form that is ax plus by plus c equals 0. So the first two examples that we did, those were in slope-intercept form. Now this time around, we have the general form. So the first thing that we're going to do is, just by looking at the general form right here, we will not be able to figure out the slope. So then it is very imperative that we change this to its slope-intercept form equivalent. So I'm gonna change this one right here. So first, we are going to, our target is to isolate y by itself. So that means we are going to subtract 3x from both sides. So minus 3x and minus 3x here. So then we can go ahead and cross out the 3x and 3x. We're left with negative y plus 4 equals negative 3x. And then from here, we want y by itself again. So we are going to subtract 4 from both sides, minus 4. So then we can go ahead and subtract, if we subtract 4 and 4, that would get crossed out. So that is negative y equals, again, please remember that you cannot have a negative 7x here. That is not the right way to do it, because others are going to think like, oh, this is negative 7x. No, because they are not, they're not like terms. So this one has an x on it, and this one doesn't have an x, so you cannot combine them together. So our answer for the right side here should be negative 3x minus 4, not negative 7x. And then from here, we want y by itself, so it should be a positive y. So that means we can divide both sides by negative 1. Divide this by negative 1 because our target is to have a positive y. So then we go ahead and we can rewrite this as y equals, that's a negative over a negative is a positive, so positive 3x. Negative over a negative is a positive, that's a 4. So then from here, we can go ahead and tell that our m for this, or our slope, is 3. So I'm going to write the m here is 3. And we are going to get the m on the other side as well. So that would be, from this equation that we have, we want y by itself. So we're going to subtract x minus x from both sides. So then we can go ahead and cross this out. So that's 3y plus 6 equals negative x. Again, we want x by itself. So then we are going to subtract 6 from both sides. Minus 6. Again, I put that not next to each other right here, or not on top of each other, because they are not like terms. So then from here, we can go ahead and cross the 6 out. So we're left with 3y equals negative x minus 6. We want y by itself, so we divide both sides by 3. We divide this by 3. We divide this by 3, so we can cross the 3 out. So we are left with y is equal to... this one is an invisible 1 before the x, which is the invisible coefficient. So we can go ahead and say negative 1/3 x minus 2, because this is a negative and a positive. So this 6 divided by 3 is 2. So then we can go ahead and say that the slope for this is negative 1/3. So again, the first question that we're going to ask is, are these two slopes the same? They are not the same. So that means these two lines that we have here are not parallel. The second question is for perpendicular. First, are their signs switched? This is positive, this is negative. Yes, so the first condition for perpendicular is met. Now the next question is, are these two fractions like opposite to each other, or have they been flipped? So let's see, this is, remember this one, if it's a whole number, it has an invisible denominator of 1. So then that's 3 over 1, and it turned out 1 over 3 here. So that means their signs have been switched. The positive and the other one is negative. And then 3 over 1, their fractions have been flipped. So pretty much like their fractions are flipped. So then we can go ahead and say that these two lines that we have there are perpendicular lines, since the condition for perpendicular, those two conditions that we established at the first slide, were met. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!